It seems that humanity has gone a long way since the first people appeared on Earth. We've invented so much cool stuff and developed new technologies. We've risen above other species after having built an advanced civilization. We've come from living in caves and cooking our food on fire to walking on the moon and creating 3D breakfasts. Does it mean we can be considered a Type 5 civilization? Oh, I see you're confused. Let me tell you about these civilization types and what they mean. The Type 1 title is given to species that have managed to harness all the available energy of their home planet. That's why this civilization is called a planetary civilization. They gather and store this energy to satisfy the demands of a growing population. We would need to boost our current energy production more than 100,000 times to get to this stage. And then we would be able to get control over all natural forces on the planet, like volcanoes, storms, or earthquakes. It's hard to believe, but it's actually a very basic level. You'll see it later. As for now, let's move to a Type 2 civilization. It can use and store energy at the scale of a star system. That's why this type is often called a stellar civilization. Experts have suggested several potential ways to do it. The most popular one is called the Dyson Sphere. This hypothetical device could encompass every single inch of a star, gathering its energy and transferring it to the planet. What would so much energy mean for the Type 2? First of all, nothing we know about could wipe out such a developed civilization. Let's say a moon-sized object entered our solar system and was heading towards Earth. No need to panic. We would be able to vaporize it as soon as we noticed it. Or maybe we'd just move our planet out of harm's way. Now, a Type 3 civilization can control energy at the immense scale of the entire host galaxy. That's the reason it's called a galactic civilization. The inhabitants of such a civilization would probably be totally different from the human race. They could be cyborgs, both biological and robotic beings. Maybe there would be colonies of robots capable of self-replication. They would spread across the galaxy, colonizing star systems. And still, these species would be restrained by the laws of physics, unless they figured out how to travel at the speed of light. At first, the scale describing civilization types didn't go beyond Type 3, but later, it was extended, and that's how Types 4 and 5 appeared. A Type 4 civilization knows how to harness energy at the scale of the universe it lives in. This could probably allow its inhabitants to live inside supermassive black holes. In any case, they would need to tap into energy sources we can't even imagine at the moment, using currently unknown laws of physics. And finally, an incredibly advanced Type 5 civilization might be living somewhere out there. If we reached this level, we would be able to manipulate energy both within our universe and other universes. Of course, at the moment, we're a very long way from achieving a Type 5 civilization, but it's not impossible. Assuming our world remains intact, we might continue advancing with every next generation. Then, a day may come when we'd be able to travel anywhere we want in the multiverse. Maybe we'd even use wormholes. Theoretical bridges using space-time that creates shortcuts, reducing travel distance and time. We'd be able to tap into mysterious dark matter to produce energy. And we would find the answers to tons of mysteries about us and the universe. But guess what? At the moment, we're not even a Type 1 civilization. Yep, we're not even on the scale yet. Duh! First of all, we're facing some physical limitations of each type of energy source. Plus, we'd need to balance them not to trigger even more climate changes and not make pollution levels rise. Scientists researching this question have concluded that humanity could potentially reach the level of Type 1. But it wouldn't happen until at least 2371.
So how alone are we in our galaxy? Crickets. Yep, we're mostly alone out here. But are there other civilizations lurking somewhere out there in the depths of the Milky Way? Could they possibly have evil intentions and be a threat to us? Hey, like we need more threats. Well, hey, let's have some fun with this. Some theorists reviewed humans' history and past actions toward one another. No miscongeniality awards there. And assuming they were somehow like us, used this to calculate the probability of space invaders. They determined that there could be 4 evil civilizations in our galaxy. The 4 could be eager for intergalactic domination, or maybe just for a good game of dominoes. They could be highly advanced in technology, or they've only just invented an evil version of game consoles. To understand how advanced these cultures could be and what to expect, there is a way to define their threat levels. A method called the KARDASHEV scale analyzes intergalactic nations' possible abilities. With 3 different levels, it reviews the amount of energy a civilization could take from their star, indicating their tech level. This only includes those that have reached interstellar communication. So any other beings out there using, let's say, space pigeons will of course be excluded. Type 1 shows that they can harness the energy from the sun, but only from what is received within their own planet, like solar power panels. Type 2 is where they can use the energy directly from the sun, like through a Dyson sphere. It's used to harness all of the sun's energy, having been built entirely around it. And lastly, Type 3, where civilization can use all elements provided by the galaxy, with the power to not only harness the energy from stars, but also black holes, even the central supermassive one. These levels are important to assess how advanced civilizations could be out there. The Milky Way is estimated to be around 13.6 billion years old. Modern humans have only been around for the last 200,000 years, and we're only a Type 1. It's scary to imagine the time other beings have had to develop. We're considered a bit of a late bloomer in comparison. Earth is, shall we say, late to the party because we're located on the outer arms of the galaxy. Mathematicians posit that more centralized star systems have had more time to progress. Now, with that in mind, how common would other intelligent beings be in the galaxy? With all the life-ending events Earth has survived, it's a miracle to have a planet like ours, and that we would be unique. Or are we? Well, there are 100 trillion stars in our galaxy, and there are up to 200 billion planets, with an estimated 300,000 exoplanets capable of sustaining the kind of life we know about. From those habitable planets, how could we tell which ones have other beings eager to send us an email? No one's had the time to individually count, of course. The Drake equation can give us some rough numbers if we take averages of a few key factors. It breaks down the criteria of how many planets with life are intelligent enough to make communication. The numbers are huge, considering how many stars might have planets. And from there, we distill it down further to those within the habitable zone in the solar system. This zone is called the Goldilocks zone, as it's not too far from the sun and not too close to it. It's just right. We reduce the numbers even further by calculating which of those habitable planets will then be able to support life. And from those random places, the equation takes the probability of how many intelligent beings will be and if they are intelligent enough to communicate. The criteria is complicated, and so it's not an easy equation to explain. But from its estimate, there could be up to 100 million planets with intelligent civilizations. But just like with Earth history or struggles, these civilizations may also have their own challenges. World-ending events should be thrown into the equation, like asteroids, solar flares, supervolcanoes, and supernova. They could also destroy themselves through technology, like AI dominance or nanotech, or by affecting their own ecosystems and running out of resources, or by just acting stupidly. If we take these into the equation, the remaining living civilizations could be around 15,000. But what could they possibly want from humans? We do have an abundance of rare earth materials that could be of value, ready to be harvested and easily collected. Besides an appealing vast amount of water they could suck dry, hydrogen is a required element of rocket fuels. Though these things aren't exactly rare in the galaxy and could be harvested easier from other closer solar systems or asteroids. Our technology might be intriguing to them. Our range of innovations on Earth, invented while being isolated in separate countries, help provide different technology paths around the world. Other civilizations could have followed a completely different route and didn't learn the importance of many things we have here on Earth, like karaoke. The same goes for applied sciences, where they may have evolved in different atmospheres with different elements. Their science would be mainly affected by that, and ours would provide them with more knowledge. Then, there's one of the rarest things in the galaxy, that Earth can support life. This would be very useful for an intergalactic traveler, rather than going through the long process of terraforming an unlivable planet. Why not just take it? With a cozy outpost, it would be a lovely little holiday destination when they need some time off from conquering other civilizations. Fortunately, they wouldn't be interested in eating us, or probably wouldn't have an appetite for anything on Earth. They would need to have similar biochemistry and require the same enzymes to process the molecules we're built from. Whew. But the most likely thing they would want is to remove any competition. The biggest threat to them is anything that would provide a challenge to their domination. But before you get too frightened by these evil civilizations, this was based on human behavior. It's possible that any beings out there could lack or avoid many of our human emotions. For instance, their capacity for anger might be limited, or they could have evolved without it. They could come from a world with a history so different from ours that they could be overly trusting, making us the bad guys. But again, they may also lack empathy and other positive traits we have. Well, let's hope they only have our nice traits. Luckily, there's a big thing that separates us from everything else. The galaxy is huge, and it takes a very long time to go anywhere, even to our closest solar systems. The fastest thing we've sent into space is the Galileo probe, which travels up to 100,000 miles per hour. Even so, it would take 72,000 years to reach the closest star system, Alpha Centauri. Still, with a newly proposed laser-guided probe that could travel at 1/5 the speed of light, it would yet take up to 20 years to make that journey. On a larger scale, the Milky Way is over 105,700 light-years across. If a civilization was even capable of light speed, it would take them hundreds of thousands of years to travel from one end to the other. With a huge distance between the small number of civilizations, the only successful contact would be through advanced interstellar travel. But to achieve such a long journey, the greater the mass to be accelerated, the more energy is required, so it's not likely anything too large will be sent. But they could travel here very quickly in a small shuttle, using the ability to break cosmic speed laws. They may already be here, watching us closely, or just binge-watching Netflix. They would need very advanced technology, and the number of species obtaining this is theorized to be only 2 out of the 15,000. That means there's a 1/100% chance of evil civilizations capable of visiting us soon. If they do know we're here, and they want something from us, it's likely to take them thousands, if not millions of years to arrive. So, we've got plenty of time to relax.
Did you know that humans are real space people? You were born in space. Heck, even I was born in space. We were all born in space. But for humans to be here on Earth, so many conditions have to be precisely correct that it's highly improbable that we even exist. But we do. First, we, and any other space creatures who might be out there, have to live on a planet orbiting a yellowish-white star, not a red star or a blue star. Not a blue star, because they burn out too quickly. In a few million years, there wouldn't be time for evolution to do its relatively slow magic and produce intelligent beings. Blue stars also tend to swell up and turn red when they collapse and explode. It makes it highly unlikely that any civilization could prosper near a blue star. Red stars which are by far the most numerous kind of stars, don't seem like good prospects for intelligent civilizations to orbit around either. Red stars are so cold and so dim that a planet that could grow a civilization must orbit very closely to the red star, which would expose the planet to intense, deadly X-ray radiation. So, though red stars are the most numerous and appear to have many planets orbiting them, red stars are a no-go for hosting intelligent, civilized life like our own. That leaves the yellowish stars, about 10% of all stars. However, an important fact must be met before considering the possibility of intelligent life living around a yellowish star. That fact is that the yellow star must be a third-generation star. Only third-generation stars will contain sufficient chemical diversity to sustain advanced life forms. Each time a star explodes, heavier, more complicated elements are created. The explosion expelled these elements and eventually found their way into a nebula. Gravity within the nebula will gradually form the next generation of stars, and so on. Our bodies need calcium for our skeletons and teeth. Our brains need zinc to help create the electrochemical signals that make us move, feel, and think. Our blood needs iron. Therefore, our bodies need to have formed around a third-generation star, and a yellow one. Amazingly, Earth has all the different elements in the universe, all 94 naturally occurring ones, from hydrogen to plutonium. Maybe that's why we're here. And we have to thank our third-generation yellow dwarf sun for that. Why yellow? Because yellow stars burn very steadily by nuclear fusion without significantly changing brightness over billions of years. If our sun became just 6% brighter or dimmer, Earth would become too hot or too cold to sustain civilized life. Fortunately, Earth is in the habitable zone around the sun. The habitable zone is where liquid water can exist on a planet. But that brings us to the second condition necessary for intelligent life to live in space: the planet itself. Recent studies with the Kepler telescope have shown that 1/4 of all yellow dwarf stars may contain Earth-like planets in the habitable zone around yellow dwarf stars. That figure is somewhat debatable. It might be as few as 1 out of every 33 yellow dwarf stars, but that's still a lot of planets orbiting yellow stars in habitable zones. So let's consider the second essential component for intelligent life in space: the planet itself. The planet that would bear intelligent civilization must have many particular characteristics that aren't easy to come by individually, and even more rare to find in combination. Most importantly, the planet must have protection against the star it's orbiting. Because stars shine by nuclear fusion in their cores, gas in the outer shell of the sun, called the corona, gets blown off into space in what's called the solar wind. Our United States satellites take constant readings of the force of the solar wind, which is mainly electrified, ionized, hydrogen nuclei, along with a smattering of atomic nuclei from the many other elements found in the sun. It's not the atmosphere that protects Earth, it's the magnetosphere that stops or deflects the dangerous solar wind, causing aurorae when the solar wind is attracted to Earth's magnetic poles and electrifies the air of the upper atmosphere like a fluorescent bulb. Without a magnetosphere surrounding it, any planet, even those in habitable zones, would be toasted by a constant rain of ionized hydrogen nuclei from its star. A planet with life on it must have a magnetosphere strong enough to deflect the solar wind. Not every planet in our solar system has a magnetosphere. The gas giant planets, Jupiter, Saturn, Uranus, and Neptune, have magnetospheres, but gas planets cannot have civilizations. Of the solid worlds, only Earth and Mercury have magnetospheres, and Mercury is too weak to stop the solar wind because of its closeness to the sun. Another protective shield that keeps the Earth safe from the sun is its atmosphere. The atmosphere is about 300 miles thick, with most of it concentrated within just 10 miles of the Earth's surface. The atmosphere protects life on Earth from both the sun's ultraviolet, UV, radiation, and X-rays. The gas, ozone, which is 3 oxygen atoms bound into a large gas molecule in the upper atmosphere, blocks most of the sun's UV radiation from reaching the ground. The planet Mars, whose atmosphere is 1,000 times thinner than the Earth's, has no ozone, and the sun's ultraviolet emissions have totally irradiated its surface. A planet must be able to stop the UV radiation from its star, so the specific composition of the atmosphere is critical for any planet to have an intelligent civilization. We've got it. but it is a rare and precarious mix. The planet must have some part of its surface solid to walk and work on. The planet must have a crust. It's pure science fiction to consider underwater civilizations or floating civilizations in the atmospheres of other planets. A planet's crust must have tectonic plates that move. This movement of tectonic plates creates the subduction of the crust. Subduction is when one tectonic plate slides under or over another, bringing the fresh matter to the surface. This renewal of the chemical properties of the planet prevents chemical equilibrium, where nothing is reactive. Earthquakes and volcanoes also contribute to the process of geochemical renewal. That's right, earthquakes and volcanoes are good. Subduction of tectonic plates, then, is another planetary essential for life. Mars doesn't have tectonic plate activity. Neither does Venus nor Mercury. Mercury is one big tectonic plate, but there's no ongoing plate activity other than slight shrinkage. One big reason these planets have no life is that there's no geochemical reactivity because there's no tectonic subduction. And that brings us to the Moon. Yes, the Moon. To say that the Moon keeps us alive may seem like a stretch, but the contribution of the Moon to life on Earth is essential. First, the gravity of the Moon as it moves through space with the Earth not only makes the ocean tides ebb and flow, it also helps the rotation of the Earth to churn or stir the magma inside the Earth. The motion of the magma inside the Earth, with its high metallic content, contributes to the creation of the Earth's magnetosphere. So, the Moon keeps us safe in space by helping Earth become a geodynamo and creating our magnetism. The Moon is the largest moon in the solar system compared to the size of the planet it orbits. Essentially, it's primary. Many people consider the Earth-Moon system to be a double planet, but that's another issue. Another thing the Moon does that keeps life safe on Earth is to hold the Earth steady. Because the Moon is gravitationally locked to the Earth, the Moon acts much like a balance pole does for a tightrope walker. Therefore, the Earth doesn't wobble very much compared to other planets. This wobble is called libration. If the Earth wobbled as much as Mars or Saturn, not only would our weather become chaotic, but farming might have been impossible. These rare or unique astronomical circumstances work together to make Earth habitable for humanity. Many other factors are not astronomical, such as evolutionary, biological, and chemical factors required for life to exist on Earth. The probabilities, or improbabilities, are multiplying. Taken all together, we are very, very lucky to be here. In fact, we're so lucky that we may have hit the jackpot. Considering all the possibilities, it's doubtful that anywhere else in the universe is as fortunate as Earth.